Afternoon everyone, my name is Jashdeep Singh, a student of PMCD Kendriya Vidyalaya and Ruskan Shift 2, and today I am here to present you all a presentation on the topic computer networks. We use internet every single day for WhatsApp, YouTube and studying. But how often do we stop to think about the invisible architecture making it all happen? Today we will uncover exactly how these networks are built and how they function. So let's begin. Here is our roadmap for today's lecture. We are going to build an understanding of computer networks step by step. We will begin by looking at the evolution of networking to understand how it all started. Let us dive deep into the section 1, the evolution of networking. The internet wasn't built overnight. So let's start from the very beginning. We need a solid definition of what exactly is a computer network. Simply, a computer network is a collection of interconnected devices. The primary goal of the connection is the sharing of information and resources. Now, these devices don't just magically connect, they communicate by sending data through physical communication channels like cables, etc., and following strict software rules which are known as protocols. Let's think of some real life example like a smart home where your smartphone and an assistant like Amazon Echo are connected with your smart bulbs, fans, etc., which are connected with a single Wi-Fi and they can communicate with each other through Wi-Fi, which is the communication channel over here, and the communication protocol is the rules using which they share information. Like when we switch on the bulb on our phone, the bulb actually switches on. Other examples of computer networks are interconnected digital devices, common communication media, and the internet. Let's move on to the next slide. As you can see, there is a quote on the screen by Stewart Kirkpatrick, who is a well-known digital media expert and journalist. He says, Hoaxes uses weaknesses in human behavior to ensure that they are replicated and distributed. In other words, hoaxes prey on the human operating system. Here, hoax is a false warning or a fake news which is there to trick you. Here, replicated means duplicated or perfectly copied. And when he says they prey on the human operating system, he means they exploit our human psychology like fears, curiosity, or excitement. So, in simple words, the quote means that fake news spreads so quickly because it hacks our feelings, not our computers. For example, when there is a fake news or a scam link, it spreads quickly through the internet. Networks are incredibly powerful at sharing data instantly, which is exactly why understanding how they work makes us more responsible digital citizens. Let's move on to the next slide. Why do we need networks? The most fundamental reason here is resource sharing. We can share a resource easily with any file, any video, etc. with the help of internet. We can communicate easily. We can access the internet, browse the web, etc. And centralized management can be made with the help of networks. For example, in office, we can print easily from any computer. We can print easily from any computer because all are connected to a single printer which is enough for one room, one hall in one office. So let's move on to the next slide. Now we look at the advantages of computer networks. So the first example is resource sharing, as we already looked earlier. The second one is improved communication. We can easily communicate with Google Meet, Zoom meeting, WhatsApp, etc. Number three is centralized data management system. We can store our data on cloud easily and get the data later when we use it. It's easy to store data on centralized management systems. Then the number four is cost reduction, and number five is easy access to information, like easy access to information and the websites. We can look about anything and study easily with Wikipedia, etc. Now let's move on to the next slide. Let's learn about the evolution of networking. The grandfather of the modern internet is ARPANET. ARPANET is Advanced Research Projects Agency Network. ARPANET was founded and funded by US Department of Defense in 1969. We can imagine it like internet with highly restricted walkie-talkie channels used only by military generals and top scientists. Crucially, it was the first network to successfully use packet switching. What is packet switching? Packet switching is breaking data into small blocks so it could survive even if the part of the network was destroyed in war. If some part of some bases are destroyed in war, still the network can connect other bases because it is connected through packet switching. Now let's move on to the next slide. In the mid 1980s, NSFNet was created, which is National Science Foundation Network. This was strictly for academic and engineering research related, so still public didn't had any access over it. Next came the internet in the 1990s, where everyone had the access. Telecom companies started coming and developed it. The internet connected the whole globe. Internet we see today was started as a military tool to communicate with each other. Let's understand the timeline of networking. In 1961, when the idea of ARPANET was first planned on paper, so ARPANET was first planned in 1961. In 1969, it officially started working by physically connected computers at UCLA and Stanford Research Institution. So UCLA is a University of California, Los Angeles. It is a university, and Stanford Research Institute is also an institute or university, and they were connected through network with in 1969 with the help of ARPANET. Next, in 1971, a huge milestone happened. Roy Tomlinson developed networking messaging, which we know today as email. So email was developed in 1971, and @ symbol was used to separate the person's name with their computer network. Like if UCLA scientist A, let's say, is talking to or communicating with Stanford Research Institute's scientist B, so UCLA UCLA's scientist address would be A@UCLA, and Stanford Research Institute's scientist address would be B@Stanford. That's why we know the name of the person which we are communicating with, and also the domain or the network which we are communicating with. Next, in 1974, the actual term internet was used. We saw the first commercial use of ARPANET under the name Telenet. Commercially, the internet or the old times internet, ARPANET, was first used as the term of Telenet commercially. Now in the 1980s, 1982, TCI/IP was introduced as the standard rule. It forced all the different computers across the world to finally speak exact same language. We'll understand about TCI/IP later in the lecture. Let's move on. In 1983, DNS system, that is domain name system, was introduced, allowing us to type easy words like google.com instead of long strings of numbers. So we could now just type google.com and the website will open. We don't need to type the whole IP address of something. Next came the 1986, where NSFNet program built a massive high-speed data highway across the US. So the high-speed data highway was built across US in 1986, and at the name of NSFNet. Then came the massive breakthrough in 1990. Tim Berners-Lee at CERN developed HTML and the URL, officially giving birth to the visual, clickable pages of World Wide Web. So World Wide Web was created in 1990 at CERN. In 1997, we started cutting the physical wires when the first version of the Wi-Fi standard was introduced. In 1997, the Wi-Fi was also introduced, and this was the whole development of the internet over the past years. So let's move on. Let's move on to the section 2, data communication terminologies. We know the history now, so now we need to learn about some core vocabulary that will be used, that is very important for understanding the computer network. Let's go to the next slide. Communication and its component. So what is communication? Communication basically is the exchange of information. Communication is basically the process of exchange of information between two or more entities when two or more computer systems or networks or computers within a network, they communicate with each other, that is, interact with each other. That is communication. In networking, information travels electronically. Communication may be wired or wireless. Communication follows predefined rules. That is, in protocols, communication follows is predefined. There are total 5 essential components of communication: sender, receiver, message, communication media, and protocols. Let's understand them in depth. Starting with sender. What is exactly sender? The device which sends the data is simply the sender. Next is receiver. The target device or the device which receives the information is simply the receiver. Next is the message. The message is the actual information, digital information that is being sent is the message. Next is communication media. That is the physical part the data travels. That is communication media. Next is the fifth and the last component, protocols. Protocols are strict software rules that make sure that the communication process is held perfectly. Take an example of ordering food from, let's say, Swiggy or Zomato. So in that case, your smartphone placing the order would be the sender, the receiver would be the restaurant, the message would be the bill or the materials ordered by you. Then protocol will make sure that the restaurant system correctly reads and understands your phone's digital request exactly as it was sent. Let's move on to the next slide. Measuring capacity. So when we build that communication media, we need to measure its capacity. Communication media's measuring capacity can be measured with bandwidth or the data transfer rate, that is DTR. Let's begin with bandwidth. Bandwidth is measured in hertz. Think of bandwidth as a highway. A 4-lane highway has more bandwidth than a one-lane dirt road because it is wider and can fit more traffic at the exact same time. That is how the bandwidth works. Next is data transfer rate, it is DTR, which is always measured in bits per second or bps. While bandwidth is how wide the highway is, DTR is how fast the cars are actually moving in that highway. Like when your phone says it's downloading a movie at 5 Mbps, you are looking at the data transfer rate. So let's move on to the next slide, which is now let's see the IP addresses. What is IP address? When a sender transmits a message, how does the network know which receiver to send it to? It uses an IP address. An IP address is a unique identification number given to every single device connected to a network. Think of an IP address as your house's postal address or your Aadhaar card number. Without it, the internet's postman simply doesn't know where to deliver your data. That's why it's very important. The purpose of IP address is device identification, communication, and routing, as I told you. And as you can see in the slide, as you can see the example in the slide, that is how IP address works. Let's move on to the next slide. Let's understand about IPv4. So there are two versions of IP addresses. One is IPv4 and one is IPv6. Let's first understand about IPv4. IPv4 is a 32-bit address system written as 4 numbers separated by dots. There are 4 numbers separated by dots and it is 32-bit address. It is still heavily used today. Think of IPv4 like our old 10-digit mobile numbers. Because billions of people are constantly buying new smartphones and smart TVs. Its biggest problem is that we are simply running out of unique 10-digit combinations to give them. Next, we move on to IPv6. To solve the global shortage, engineers created IPv6. IPv6 is a massive 128-bit address system. Upgrading to IPv6 is like upgrading our phone numbers from 10 digits to 20 to 30 digits, which is absolute very big advantage. As now more devices can communicate easily as there will be no repetition of IP addresses. Now let's understand what's exactly the difference between IPv4 and IPv6 with an image. As you can see in the image, IPv4 is 32-bit address as we know, and IPv6 is 128-bit. IPv4 has limited addresses, but IPv6 is very vast address space. IPsec is a security system used by IPv6, which is better than IPv4's security system NAT. Now let's move on to the next slide. Switching techniques, circuit switching and packet switching. So let's learn about the two switching techniques also now. Circuit switching. Circuit switching creates a dedicated logged path before communication begins. It is like booking a VIP train track where absolutely no other trains are allowed to drive until your trip is over. This is how old landline telephones work. What is packet switching then? Packet switching is when data is divided to tiny blocks called packets. Packet switching is like ripping a 100-page book apart, putting each page into a separate envelope and mailing them to different post offices. They travel independently, take whatever route has the least traffic, and are carefully put back together by the receiver. This highly efficient method is what powers the modern internet. let's see the advantages. So the example of the circuit switching, as we know, is traditional telephone networks. An example of packet switching is sending files through email, WhatsApp, etc. Now let's move on to the next slide. So now we have completed this section. Now we will move on to the transmission media. We know the vocabulary, so now we can look at the actual physical cables and the invisible waves that connects our devices together. Let's first see what actually is transmission media. The circuit switching is reliable and has consistent speed, whereas packet switching is efficient and cost effective and is used by the internet view. Transmission media is simply the channel through which the data travels from sender to the receiver. Just like physical roads connects different cities, transmission media is the road that connects our computer that connects our computers. It is divided into two main categories: wired media and wireless media. Wired media is where the signal travels through a physical cable, and in wireless media, where the signal travels through the air, as like 5G roads, etc., where the wireless media is used or Wi-Fi. The type of media you choose determines the speed, reliability, and the total cost of your network. Let's first understand about wired communication media. There are three types of wired communication media: twisted pair cable, coaxial cable, and fiber optic cable. First, let's understand about twisted pair cable. Inside, copper wire are twisted together. So that copper wires are just twisted together. And so these twisting naturally reduces outside electrical noises and keeps the signal clean. This is a standard yellow or blue LAN cable. Use this to connect different computers. Advantage: twisting reduces electromagnetic interference. That this twisting naturally reduces the outside electrical noise, keeping the signal clean. Next example: standard Ethernet cables connected to PCs. Normal cables that we connect to PCs is twisted pair cable. Next is coaxial cable. Coaxial cable. Coaxial cable is copper wire that's surrounded by insulation and braided steel. It is surrounded by heavy seal because it can carry data for long distances also. And its example is like cable televisions that we used like Airtel, this Tata Sky, example, Tata Sky, etc. The third one is the fiber optic cable. Fiber optic cable is the fastest technology in the world. Instead of electricity, it uses microscopic glass strands to transmit data as rapid pulse of lights. That makes it incredibly fast and completely immune to outside noise. High-speed broadband services like GeoFiber uses fiber optics. Now let's move on to the next slide. Now let's understand about the wireless communication media. There are three different types of wireless communication media used by computer networks: radio waves, microwaves, and infrared waves. These all waves have different frequency, and the least frequency is of radio waves. Radio waves are low frequency electromagnetic waves. These are omnidirectional, that is, they travel in all directions. Example: AM, FM radio, normal radio that was used for news, etc. information is used radio waves. Next is microwaves, which is high frequency line of sight transmission. It travels in straight lines. Example: cell phone towers, satellite links. which we use today, are microwaves. Next is infrared waves. It is very high frequency and short range wave. It cannot penetrate solid object, that means it cannot transfer through some object that is solid. Requirements: strict line of sight, example television remote controls, wireless keyboards. So the remote that we use of the televisions, it it uses infrared waves, so it cannot travel to some solid objects. It should be in a straight line. Infrared waves can be blocked physically, so we have to make it travel in a straight line. Now let's go to the next slide. So we have completed one section. Now let's move on to section 4, network devices. We have understood about cables and wireless signals. Now let's look at the actual hardware machines we plug into the cables to manage the heavy flow of the net traffic. Let's start with modem. What is modem? Modem, the full form of modem is modulator demodulator. Think of a modem as a language translator. Your computer simply speaks zeros and ones. But traditional telephone cables were built to manage analog sound waves. Modem translates your computer's digital text into analog wave to travel across, and the receiver modem demodulates, that is, translates back that wave into digital text so the computer receiving the data can read it. Example: broadband per modem. Now let's move on to the next slide. Ethernet card. What is Ethernet card? Ethernet card is highly referred. Ethernet card, which is referred to as NIC, is Network Interface Card. This is a physical green circuit board installed inside our computer that allows it to process network data. It connects a computer to a wired network, provides a unique MAC address, enables data transmission. Every single NIC has some different MAC address, which is something different from IP address. MAC address is permanent, it cannot be changed, but IP addresses changes. It's your permanent number of your computer, that is MAC address. Example of Ethernet card is built-in LAN port in a desktop computer. Now let's move on to the next slide. Now let's learn about RJ45 connector and repeater. The RJ45 connector is simply a 8-pin plastic connector found at the very ends of an Ethernet cable. It is the part that makes a clicking sound when you plug into your laptop or a computer. Next is repeater. When electrical signals travels down very long cables, they lose energy and get weak. Think of a repeater like a Wi-Fi extender in a large house. It catches the weak, tired signal, cleans it and boosts it back to 100% full strength before sending it further down the line. Basically, it just extends the distance of the network. The repeater's example is that it is used in large buildings where the cable length is long, so we can use it there. Next comes hub, switch and router. To connect multiple computers in one room, we use a hub or a switch. Let's start with hub. A hub is a device which connects multiple devices. It sends data to all operated devices, operates at physical layer. So if you want to send a file to one specific friend in a room, a hub acts as a megaphone. It blindly copies the data and shouts it out to all the devices which are connected to the network. This creates a massive amount of unnecessary network. That is why its limitations can create unnecessary traffic. Next is a switch. Switch is, however, somewhat intelligent. It also connects multiple devices, but it sends data only to the intended destination, the destination or the computer to which we want to send the data, and uses the MAC address, that is embassy address, that is the address of our network of computer. Its advantages are it is faster than hub. Of course, it would be faster because it directly sends and there is no unnecessary traffic created. Hence, it reduces the network traffic. Next, next comes the router. The router connects different network, directs data packets, provide internet access. While switch connect individual computers together, a router connects entire network together. Think of a router like a traffic police officer at a busy intersection. It constantly reads the IP addresses to direct your data packets down the fastest possible path to the internet. Example, home Wi-Fi router. Next comes the gateway. What is a gateway? So a gateway is a specialized translator used to connect to completely different networks that operates entirely different routes or protocols. It acts as a translator between two different types of networks which uses different type of language maybe and can easily talk to each other. Example, organization network connected to the internet. Next comes the Wi-Fi card. Wi-Fi card does the exact same job as the Ethernet card we discussed earlier. The only difference is that instead of needing of a physical cable to plug in, it contains microscopic radio antenna to allow wireless communication with home router or mobile hotspot. Example, wireless adapter in a laptop. Now we have ended this section 4. Now let's move on to section 5, network topologies and network types. Now we understand the hardware, so now let's understand how we group different types of networks with respect to the physical size and the blueprints we use to bind them together. First, let's learn about PAN, which means personal area networks. Networks, it is the smallest type of network. A PAN operates within a very short range and it covers just a few meters. It is generally centered around a single person only. Every time you pair wireless earbuds via Bluetooth or share a photo using quick share of Android or airdrop it in an iPhone, it all creates a personal area network. Example, Bluetooth connected smartwatch connected to a smartphone, wireless earbud. These all connect personal devices only, and hence it is called personal area network. The next step up is LAN or local area network. A LAN network is confined to a relatively small area. It covers slightly more area than PAN. We can assume a LAN to be a small office room where all the computers are connected to a single server where all the data are stored, where different computers are connected. Its features include high speed and secure communication, commonly used in schools and offices. Examples, computer lab, office network, or network. Next comes MAN, which is Metropolitan Area Networks. MAN covers a city or a large town. It connects multiple different LANs, that is, multiple different local area with the help of man. It is metropolitan area network. Man is larger than land but is smaller than van, about which we will understand in a few minutes. Let's first look at the examples. Examples of man are city-wide cable TV network, municipal communication networks, CCTV camera management system in the city, all comes under WAN. Now let's learn about WAN, that is wide area network. It is the largest category of network. It can connect different cities, different countries, or even different continents. It uses public and private communication channels. For example, internet, which is the largest WAN in the world. Let's understand about network topologies. What is network topology? Network topology is simply a physical or logical arrangement of devices in a network. How different devices are arranged in a network. That is network topology. There are three types of network topology in the syllabus: bus topology, star topology, and trees topology. What are the importance of topologies? They affect performance and cost, and also the reliability of the network. Let's start with the bus topology. But in bus topology, every single computer is connected to one single long backbone cable. It is very simple and cheap to set up. However, even if one of the computers stops working, the network completely fails. That is, it's very big limitation, but it's easy to install. Its example is small temporary networks. Star topology.
Star topology: when all the devices are connected to a central hub or switch, the topology there is star topology. Even if one of the cable fails in the star topology, it only affects one node, and it is also easy to install and modify. Its limitations include failure of the central hub stops the entire network, and it requires more cable length than bus topology. Example: high-speed home and office local area networks. Now let's move on to tree topology.
Now comes the next topology, which is tree topology. Tree topology is combination of both bus and star topology. It is very suitable for large organization. It is scalable, easy to expand. Example, university campus network. So in this, as you can see in the image, there are some there is a backbone cable which connects different type of uh, bus networks which are all connected to one backbone cable, and it can be said to be a mixture of bus and star topology. We have now completed all the topologies also and the types of network. Now let's come to the sixth section, network protocols. So we will learn about different types of protocols like HTTP, FTP, PPP, SMTP, TCP/IP, POP3, HTTPS, Telnet, and VoIP. So let's begin with learning what exactly is a protocol. A protocol is a set of rules that governs communication between devices. As we know earlier also, it is a set of rules which governs the communication between devices. What is it? Why is it important? It is important because it standardizes the communication, it ensures accuracy, it enables reliable data transfer. Its examples are TCP/IP protocols, and a lot of examples that we will learn today. Let's start with HTTP and HTTPS. What is HTTP and HTTPS? Its full form are Hypertext Transfer Protocol, that is HTTP, and when we add secure to it, it's HTTPS. So it is similar overall that these protocols are used to transfer the web pages and standard web communication. It is a standard web communication protocol we use to surf on the internet. And what is the difference between HTTP and HTTPS? It's simple. HTTPS is simply the secure and more encrypted communication that occurs than the HTTP. As you can see in the image, HTTP is not safe, but HTTPS is safe communication protocol. Next comes SMTP and POP3. SMTP and POP3. SMTP is Simple Mail Transfer Protocol. POP3 is Post Office Protocol version 3. SMPT is used for sending emails and POP3 is used for the receiving emails. Its example is sending and receiving emails to Gmail, Outlook. Outlook is Microsoft's email type of thing. Microsoft accounts email is Outlook, and when we send mails, SMTP protocol is used when we send mails, and POP3 is used when we receive mails. Next comes TCP/IP. Its full form is Transmission Control Protocol/Internet Protocol. TCP/IP is the backbone of the internet. TCP ensures reliable delivery. IP handles addressing and routing. It is the foundation of the internet communication. So, why is it important? Let's take an example. Let's take an example of Amazon delivery. TCP takes a massive digital file, breaks it down into small carry-to-carry boxes, address packets, and ensure reliable delivery. Whereas IP acts as a shipping label. IP acts as a label that is there on the outside of the box, handling the addressing and routing of the parcels to the exact delivery address. That's why TCP and IP protocol is quite important. Next comes the Telnet and VoIP. What is Telnet? Telnet is an older text-based rule used strictly for remote login. Allows a network admin to securely access and control a distant computer as if they are sitting right in front of it. In VoIP, which is Voice over Internet Protocol, it allows us to make video, voice or and video call over the internet and is used for internet calling. VoIP instantly turns our voices into data packets and sends it across the web just like a regular file. Let's move on to the last section, Introduction to Web Services. Now let's first learn about the basic web technologies that are www, HTML and XML. www stands for World Wide Web. It is a collection of interconnected web pages that websites we surf on the Google in the browser. When we type something, we get lists of websites. When we click on one, that's all controlled under the World Wide Web. This collection of all the web pages. Even Google.com is a World Wide Web, which is www.google.com. Next comes the HTML. HTML is hypertext markup language. It is quite important language used to create the web pages. It is the backbone of that web pages. That is how they are created. With HTML, CSS and JavaScript is used. CSS is used to design the website and JavaScript is used to make the buttons in the website functionable. Next is XML. XML is Extensible Markup Language. It is used to store and transfer data. So the data can be stored and transferred using XML. XML is basically like a servers that works behind that we can see to store and transport data in the web pages. Next comes website addressing, domain name and URL. How do we know that which website it is? First, we have a protocol name that you can see in the image, hypertext transfer. Then we have subdomain name that is www, it is worldwide web. Then we have the domain name and top level domain DLT, that is .com. In this case, is the domain name. What is domain name? Domain name is human readable website name. That is the website's name actually that we use to signify that it is that website. A URL is Uniform Resource Locator. It is a complete address of the web page. This whole address that you can see in the image is a URL. Example, domain name google.com, URL you can see in the site http. Now let's go forward to website and web browsers. What is a website? A website is simply a collection of web pages. Website is simply a collection of related web pages accessible through the internet. We can access different websites through the internet, and access those websites we use web browsers, which are simply the software used to access the websites. Examples can be Chrome, Firefox, Microsoft Edge, Safari, etc. These all are the web browsers used. Next comes servers and hosting. Web servers. What is web server? Web server is simply the server is where something is stored. The files, different files are stored, different data is stored. It sends web pages to the users. The data of the web pages is stored there, and the data is sent through network to the user. And hence it is very important. What is web hosting? It is a commercial service which we have to pay for the storage space on the massive web servers, making your personal website available online to the entire public. Next comes domain name system, DNS. As we talked about, is simply a program which converts the domain name into IP addresses. It helps browsers locate websites. We don't need to write the IP address of google.com. We just write google.com and it just converts it into IP address automatically. It makes us easy to access different types of websites. Finally, we have completed all the concepts, and now let's move on to a quiz. I have given the link on the screen also and in the description also. You can see how much have you learned with the help of 15 questions in the quiz. Now, as we have learned all the topics, now there will be a 15-question quiz. The rules are simple. I will read the question, I will read the options, then I will start a 10-second timer, and when the timer ends, I will mark the option that is correct and tell why is it correct. Are you ready for it? So let's begin. Let's start with the first question. A large manufacturing plant is setting up a local network on its factory floor. The environment has a heavy machinery that generates massive amount of electromagnetic interference. Which transmission medium should the network engineering choose to guarantee zero data corruption? Option A, shielded twisted pair cable. Option B, coaxial cable. Option C, fiber optic cable. Option D, high frequency microwaves. Your 10 seconds time starts now. And your time is up. The correct answer is fiber optic cable. As we all know, fiber optic cables transmit data using light signals, not electrical signals. Therefore, the EMI from heavy machinery cannot affect the transmission. Therefore, it is the most reliable choice here. Now, let's move on to the second question, which is the principal of a school wants to upgrade the computer lab. Currently, whenever one student sends a file to the teacher, the network slows down for everyone else because the data is broadcasted to every single computer in the room. Which device should the school purchase to replace their current hardware and solve this issue? Option A, repeater. Option B, gateway. Option C, switch. Or option D, modem. Your time starts now. So the correct answer here is option C, switch. Because the switch sends the desired data to the desired destination of the computer we want to, and this will reduce the network traffic and improve the speed. Now let's move on to the next question, question number 3. Rahul, a freelance video editor based in Delhi, needs to securely send a massive 50 GB raw video file to a production server located in Mumbai. Standard web uploads HTTP keep falling, keep failing due to the file size. Which protocol is explicitly designed for this task? Option A, POP3, option B, Telnet, option C, FTP, and option D, VoIP. Your time starts now. So the correct option is option C, FTP, because FTP, file transfer protocol, is specially designed for transferring large files between computers over a network. So it can be used for uploading and downloading large set of files. Now let's move on to the fourth question, which is an assertion reason type question. We have to read the statements and choose the correct option. Assertion. Infrared waves. Infrared waves are strictly used for short-range communication like television remotes and wireless mice. Reason. Infrared waves have very high frequencies and cannot physically penetrate solid objects like walls. Option A, both A and R are true, and R is the correct explanation of A. Option B, both A and R are true, but R is not the correct explanation of A. Option C, A is true, but R is false. Option D, A is false, but R is true. You have 10 seconds, your time starts now. So your time has ended. The correct answer for this question is option A. Both A and R are true, and R is the correct explanation of A. Question number 5. Read the statements below and choose the correct option. It is also an assertion reason type question. Assertion here is in a star topology, if the central hub or switch fails, the entire network will go offline. Reason in a star topology, all devices share a single central communication cable backbone to transmit data. The correct option here is option C. A is true, but R is false. Because the reason here is in a star topology, all devices share a single central communication cable backbone, which is wrong. It is wrong because this statement is of bus topology, not star topology. Now let's move on to the next question. Question number 6. Which switching technique does the modern internet use to break data into small blocks that travel independently via multiple routes to reach the destination? Option A circuit switching, option B node switching, option C packet switching, option D dedicated switching. Your time starts now. So the correct answer here is option C packet switching. Because the modern internet uses packet switching, that is, it divides the data into different parts, small blocks, because and its small blocks travels independently at fastest route and reach the destination. Next question, question number 7. In the context of web servers, what is primary difference between HTML and XML? Option A, HTML is used to transport data while XML is used to display data. Option B, HTML dictates the visual layout of the website while XML structures and transports raw data. Option C, HTML is used for secure banking while XML is used for basic blocks. Option D, there is no difference, they are interchangeable protocols. Your time starts now. The correct answer here is option B. HTML dictates the visual layout of a web page, while XML structures and transports data. This is a very simple question. No explanation needed. Question number 8. What was the defining feature of ARPANET when it was developed by the US Department of Defense in 1969? Option A, it was the first network to use fiber optics cable globally. Option B, it was the first network to successfully implement packet switching. Option C, it was designed exclusively to host commercial websites. Or option D, it was the first wireless satellite network. Your time starts now. And the answer is option B. It was the first network to successfully implement packet switching. Question number 9. The speed at which the data actually travels over a network is called data transfer rate (DTR). Which of the following is a correct unit for measuring DTR? Option A megahertz MHz, option B gigabytes per hour GBPH, option C megabytes per second MBPS, option D kilohertz. Time starts now. Answer for this question is option C megabytes per second. Question number 10. Which hardware device or software is required to connect two entirely different networks that speak completely different protocols? Example, a legacy main framework to a modern internet. Option A gateway, option B router, option C switch, option D Ethernet card. Your time starts now. Answer is option A gateway. The next question is question number 11. This is a multiple choice question. A modern startup relies heavily on remote work. They require employees to browse companies' databases securely without hackers interrupting passwords, and they conduct daily team meetings via internet voice calls. Which specific protocols are essential for these two tasks? Option A HTTPS, option B POP3, option C VoIP, option D FTP. Your time starts now. And the answer is option A HTTPS and VoIP. Option C, option A and C. As A is HTTPS is required for the website and VoIP is required for voice calls. Next question, question number 12. When analyzing data communication terminologies, which of the following statements accurately describe bandwidth? It is a difference between the highest and the lowest frequency of a channel. It is measured in units like bits per second, bps, and megabits per second, mbps. Or option C, it determines the maximum volume of a data that can be transmitted in a fixed time. Or option D, it acts as a physical router for the data packets. Your time starts now. The answer is option A and C. A, it is the difference between the highest and the lowest frequency of the channel. C, it determines the maximum volume of the data that can be transmitted in a fixed time. These are the definitions of bandwidth. Next question, question number 13. Email communication requires different rules for pushing and pulling messages. Which of the following protocols are exclusively associated with managing emails? Option A SMTP, option B Telnet, option C POP3, option D PPP. And your time starts now. So the answer is A SMTP and option C POP3, as SMTP is required for sending mails and POP3 is required for receiving them. Next question is question number 14. Priya connects her wireless earbuds to her smartphone to listen music, while her school connects all the computers in a building together using cables and a switch. Identify the correct network types formed in these scenarios. Option A, Priya has created a man, Priya has created a band, the school has created a van, the school has created a land. Your time starts now. And the answer is option B and D. Option B, Priya has created a band and the school has created a LAN. Option D, Priya has created a PAN personal area network because he has connected wirelessly in a small region, whereas school has created a LAN has connected a bigger or local interface, that is a local area network. Now we move on to the last question, which is question number 15. Which of the following statements correctly identify the limitations and characteristics of unguided, that is wireless transmission media? Option A, radio waves are omnidirectional and can easily penetrate solid walls. Microwaves requires a strict line of sight, which is why cell towers are built at high elevations. Option C, infrared waves are the best choice for connecting different networks across cities. Option D, wireless media relies on physical copper cores to prevent electromagnetic interferences. And your time starts now. And the correct answer here is A and B. And B, microwaves requires a strict line of sight, which is why cell towers are built at high elevations. So this was the whole quiz of 15 questions. Comment down your quiz scores, and I hope you liked and understood the lecture. Thank you for watching and have a nice day ahead.